All right, the third question. A hand grip dynamometer like the one shown in figure 9 was used to measure grip strength for a sample of 25 people. That's our sample size. The cross-sectional area of the forearm used in the test was also measured. Okay, the data is available in file that's given in SPSS. What is the question asking us? The question is asking us, a scatter plot is a useful graphical tool for investigating possible relationship between two numerical variables. Okay, scatter plot for two numerical variables. Produce a scatter plot with forearm size on the x-axis and grip strength on the y-axis, and then describe the relationship between these two variables. Okay, if we produce this scatter plot with SPSS, we will get such an output. Okay, here we've got the x-axis and the forearm, and then the y-axis the grip strength. And these values that you see are actually 25 observations that we have. And if I draw a straight line in here, most of them are close to this straight line. And the relationship is increasing, right? It's not something like that. It's not like that. That would be decreasing, but that's what we have in here is actually increasing. Okay, we can simply interpret the results and say that the results, the relationship is positive and it is increasing, and it is pretty strong. Okay, how do we interpret that, whether it is strong or not, based on the observations? If the closer they are to this straight line, the stronger is the relationship. If they are scattered around like that, then we say that it's not probably a strong relationship. Okay. That's about the first one. What is the second one? Provide the equation for the linear regression model forearm size and grip strength, and then interpret the numbers B0 and B1 in the regression equation. If we want to interpret the results, well, first of all, we need to carry out one SPSS analysis, which will give us these tables in here. Okay, what are they? Let's go through them and see what we need. First of all, what we need, we want to write the equation, linear regression equation. The linear regression equation looks like this. Y hat is equal to B0 plus B1 times X. So B0 is intercept and B1 is a slope. And X obviously is our independent variable or forearm size in here, and Y is our dependent variable or grip strength. That's what we want to measure. Okay, what is B0 and B1? B0 and B1, if we look at their coefficients, if we look at here, B1 is intercept constant, is here, and B1 is here. So minus 28 and 10, that would be our B0 and B1. Then Y hat, you simply replace them, minus 28 point, what was the number? 28.863 plus 10.703 times X. That's it. That's our linear regression equation. Okay. What else we need? That's all about it. We need to interpret B0 and B1. Oh, okay. B0 and B1. How do you interpret that? B0 is intercept. Intercept is the value, intercept is the value of response variable, is the value of Y hat when X is equal to 0. Depending on your question, x and y could be different variables, but in this question, x is forearm size and y is grip strength as given in here. That's the intercept. What is the slope? How do you interpret that? A slope means B1, means if we increase x by 1 unit, how much y increases? That's it. That's how you interpret the slope, okay? Many students have problems interpreting and writing this equation. Simply write this equation and then replace the B null and B1 values from the SPSS output. That's when we say write the linear regression equation, that's what we want. And then you need to replace the values and write this equation out. Don't replace anything for x and y in the linear equation, okay? If you want to predict something, then that's when you can replace x values to find out the y values, the predicted value. We will see this in this question now. Because in part C, the question is asking, use the regression equation to predict the grip strength of an individual with forearm cross-sectional area of 35. That means if x is equal to 35, then what is the value of y hat? Simply replace x in here, 35, and then multiply by this value and sum of this value. You will find the y hat predicted value. The y hat, that would be what is it? We've got in here. That would be 345.64 Newton. That's it. Part D is asking how much the variation in grip strength is accounted, for in the linear regression with the arm cross-sectional area as a predictor. In order to answer this question, we need to interpret the results in here, okay? Model summary. What we need is R square. R square tells us that how much of variation in y, how much of variation in response variable in response variable, okay, response variable can be explained by this regression model, by this regression equation or model. That's what we are looking for, okay? And in this question, it is 82, that's the value. That means 82.2% of the variation in y can be explained by this regression equation. Okay, that's about the part D. What about the part E? The part E is asking us, is there a significant relationship between the grip strength and arm cross-sectional area? Be sure to include these values: null and alternative, test statistic, null distribution, p-value, your conclusion. This is a pretty standard questions. So I highly recommend you to master in this sort of questions, how to write the null and alternative hypothesis, how to extract the results and report test statistic, null distribution, p-value, and then draw an appropriate conclusion. In this test, what is the null and alternative hypothesis? The null and alternative hypothesis is actually, okay. The null and alternative hypothesis in this question is what we are actually looking for, the relationship between these two variables, between the explanatory and response variable. We want to see if B1 is equal to 0 or not equal to 0. Why B1? Because B1 is showing us the relationship between X and Y, between independent and response variables. That's what we are looking for. That would be an alternative and null hypothesis. What is the test statistic? If we go to this table again in here, we can see which one is showing us B1. This is actually what is showing us Fourier arm size. That's what is showing us B1. Okay, and this is our test statistic. We can see 10.290. And what is the null distribution for this one? The null distribution for this equation would be, if H null is true, we say it's T with n minus 2 degrees of freedom. Okay, note that this is n minus 2. It's not n minus 1, all right? So we've got different degrees of freedom for independent sample t-test, paired sample t-test, and this linear equation for the coefficients, testing the coefficient. So n minus 2, what is n? N is 25. That would be t with 23 degrees of freedom. That's our null distribution. And finally, we want to say what is the p-value and make a decision. That's p-value, and it's because it's smaller than 0.05, we reject the null hypothesis and we say there is a relationship between Fourier arm size and grip strengths. That's about the part E. Part F is asking us provide a 99% confidence interval for the expected change in grip strength if Fourier arm cross-sectional area increases by 1 centimeter square. In order to answer this question, you need to know what is the equation for constructing a confidence interval. The equation for constructing a confidence interval is actually this. A slope plus minus T star times standard error of slope. We've got this B1 and we've got this standard error of B1. What are they? We've got the B1 and standard error of B1 in the table here. Yeah. Here is the B1. Here is the B1 and here is the standard error of B1. So you replace these two values and you can find that the T star value based on the confidence interval that we want. So we are looking for 99% confidence interval. That means probability of T between here, T star is equal to 99% or 0.99. What we want you need to figure out what is T star value in here. Okay, so you figure out this T star value is 2.81. We will give you a few options that you need to choose in the exam, right? Then simply replace these values there. So B1 is 10.70 plus minus 2.81 times 1.4. That would give us the confidence interval. One times sum it up and the other time deduct its value. That would be 7.78 and 13.62. That's our confidence interval. That means by 99% probability, the value would fall in this interval. All right. The last section of the third question is asking for the assumptions. What are the assumptions of your analysis? Again, I suggest you to write down the assumptions. Maybe in your cheat sheet, you may need it, but it's always good to hold them because it's hard to remember always what are the assumptions. So the assumptions for this regression model is a bit longer. We've got 4 assumptions, all right? First, observations are independent within each sample. Second, there is a linear relationship between them. There is a linear relationship between what? Between the mean of x, the mean of explanatory variable, and response variable. Then, third assumptions, residuals have constant variance. And finally, residuals are normally distributed. How do we test that? Again, let's start from the first one. In order to test whether they're independent or not, you need to go back and read the question and see if there is any information given or you have any reasonable justification that they are independent. If you read the questions, we will see that there is actually no information given that they are independent. So we can say that this assumption may not be met. In order to test these 3 assumptions, what we need to do is to plot the residuals versus the fitted value for the regression model. If you do that, you will see such a graph. You can carry out this graph and generate this graph in SPSS. All right, let's see what do we have in here. So we can see that in this graph, we have no pattern, right? They're like scattered around, right? They're all scattered around. Because they're scattered around, we say that there is no pattern, and we can say that they have constant variance. Okay? Then second thing is, there is no trend and no specific relationship between these values. We can say that based on this, there is a linear relationship between these 2 variables. Okay? So the linear relationship and constant variance we figure out based on the plot that we show, the residual versus fitted values. Okay? And finally, to know whether they are normally populated or not, we need to plot this graph in here, this graph in here, normal quantile plot. You see, most of these values lie around this straight line. That's why we can say that the normality assumptions is not violated and it appears to be normal. It's important to write this correctly. So we've given you the full information here that there is figure 13 includes a normal quantile plot because the points generally fall along the line in the normal quantile plot. The assumptions of normal residuals appears reasonable. I guess that's it about the third question. I hope that it has been helpful for you. Sorry again for, I apologize for the problems that we had for the online session. but hopefully you can watch these over and over and solve some of your problems before the exam. If you have any questions, put your comments below and I will get back to you. Good luck with the exam.